So what we are going to see today is one of the questions which was asked in Anthropology Paper 1 2020, which is 5e genetic drift. And before going into the genetic drift question, we have to know the basics of what is a gene, what is an allele, what is evolution, what is natural selection as proposed by Darwin for evolution, and then we'll understand what is this genetic drift. So before this going to this topic, you should understand that each cell will have something called as a nucleus. So cells have a nucleus, and if you zoom into this nucleus, you will find something called as, so this is the nucleus. So you will have a cell, and inside that cell there is a nucleus, and if you zoom into that nucleus, you will find something called as chromosome, and this chromosome will have a layer or a ladder of nucleotides which are called as gene. This gene codes for a particular trait. So this gene codes for a particular trait. I will assume that I will give the example of, for example, the gene in this case red is coding for black skin. So I will assume that this is coding for a black skin color. In normal way, skin color is deciphered based on a large number of genes. It is not based on one single gene, but for the sake of example, I am taking a gene in a chromosome which is coding for a particular trait, which is skin color. But as you should know, in a population, it is not the only color. Only skin color is not black. Rather, there are many varieties of color. But so I will assume that there is a population in which this gene is present, and it codes for black. There is also another gene or the same place, different varieties there, coding for the same trait, skin color, but the same gene, but a different variety, and this variety codes for white. So these two things, if you see these two things, this gene for black and white skin actually code for the same trait, which is skin color, but there are two variations, and hence they are called as alleles. So genes having coding for the same trait but having different variations is called as alleles. So in a population, if you see, in a population, there is a chance that I am assuming there is chance that this gene or this allele frequency, so frequency of alleles of white is 0.5. So if you see, it is equal, I am assuming equal. So a population will have equal frequency of white and black gene. But this is the normal concept of gene, frequency, allele, everything. But now we come to this concept called as evolution. What is this evolution? What is evolution? You have to know. So evolution is basically change. What is the change in allele frequency in a population from one generation to the next? So this is the concept of evolution. Change in allele frequency. You have to have a change in frequency of allele in order to have evolution. And how does this happen? There are many ways. So and the one way is, and how do you change the allele frequency? There are many ways. One way is Darwin's natural selection. I'll use two things which are in syllabus. One is Darwin's natural selection, the other is genetic drift. So first I'll show you how Darwin's, so how what is the difference between these two things is very essential for understanding of genetic drift. So how does Darwin's natural selection works? Natural selection. So how does natural selection work? I'll take the same example as skin color. I'll take the same example of skin color. If you see, you would know that human beings originated in a place called as Africa. That is the African continent, and you have to know that this African continent, or it lies in the equator. It lies in the equator. The sunlight is more, so sunlight is very high. So when you have huge sunlight, so what will happen? So now you see the gene frequency. Now we will see the population. And as I had said, red color is for population of coloring, the skin color trait for black, and blue for white. So here you see sunlight is more, and hence you will have more skin color to black skin color for protection of sunlight. What is this protection means? It protects from the harmful UV rays. So sunlights have a component called as UV rate, and if you are allowing a large amount of sunlight UV rays into your body, it can damage your metabolism, and hence this black skin, or black skin with the melanin, it codes for a pigment called as melanin, actually prevents all these, or most of the UV rays are prevented from entering your body, and helps prevention of harmful effects. But this is the case in equator. But you should also be knowing that there was a migration at around 45,000 BC, which is called as the Upper Paleolithic, which comes in your syllabus. But in this 45,000 BC, they are human beings migrated to a place called as temperate region. And you should know in geography that temperate region have very less sunlight. Very less sunlight. When you have very less sunlight, you cannot, you have to have or you have to allow penetration of UV. You have to allow penetration of UV because your body manufactured something called as vitamin D. This is manufactured only using sunlight, and in this place, if you don't allow sunlight, or which is the smaller amount of sunlight which is present in the temperate region, if you are not allowing, the vitamin D will not be manufactured, and hence what you do is that you code for the skin color white. So what will happen is that in this population, see this, now the population, in this population you will have more genes for white color, more genes for white color, so less genes for black color. Why? Because in this area the nature selects. So see this, nature selects, no, so natural selection. So this is what is called as Darwin's natural selection. Nature selects people with a particular trait, able to survive better in the conditions given. And but if you see this, see here, so what is this change? You see this, so according to this natural selection, a population which was having black skinned color has now changed here into white. So the transition from black to white, so isn't it evolution? So this is what is called as evolution. That is, now there is a change in allele frequency. So there is a change in allele frequency. So there is a change in allele frequency of a population over generation. So a change in allele frequency from a gene which coded for black to white is called as Darwin's natural selection of evolution. So this is the basics you have to know in order for us to proceed into something called as genetic drift. So as I said, what is genetic drift? So now coming to this concept, because we have to have a foundation of what is natural selection or natural selection of evolution of gene in order to understand what is genetic drift. So same way, now change in allelic frequency happens, but how does it happen? So I will take an example of a population. I'll take an example of population which has this allele or this gene, and another population this gene, same. But here I will add one more thing. I will say that the gene has, for understanding purposes, gene having this red color speaks language 1, blue speaks language 2. But you should know very well that genes does not code for cultural phenomena as languages. Genes code for biological phenomena. But for the understanding purposes, I have taken this example. But what happens is that there arises an environmental catastrophe. Some environmental catastrophe arises, anything, any flood or earthquake, whatever thing. What will happen is that in stage 2, what happens is that this environmental destruction removes the population which is speaking what is called as language 1, purposefully, or because of some chance. So this is the point. Because of some chance or accident, you should say chance or accident, the population speaking language 1 having a gene red has been removed, and hence what you will find the rest of the population, happens. But over a period of time, now what happens is that in stage 3, over a period of time, the population speaking red will go away and the population speaking blue will actually colonize. This is, if you see, this happened because of chance. And you should also know, same thing as evolution. What is evolution? Change in allele frequency. Now see the change in allele frequency which is happening. Change in allele frequency happened from a red color gene, or you should say equal frequency was there. Red and blue was in equal amount. But now what has happened, because of chance and environmental destruction, blue gene has occurred. But this is change in allele frequency, and the same as evolution is change in genetic or allelic frequency. And this is the difference between natural selection and a genetic drift. And this is what you have to write now. Have two things. First is, you should know two things. First is bottleneck effect. What is this bottleneck effect? Is the same thing. See this? There is a bottle. Let us assume there is a bottle. And in this bottle, there are, this is the population. So this bottle is nothing but a population. So this bottle is nothing but a population. So I am assuming a population. This population has equal amounts. And what happens is that there is an environmental, this is the neck, bottleneck. There is an environmental destruction. There is an environmental catastrophe or environmental problem. Some flood is coming, from some earthquake is coming, something is coming and removing the population which has red color gene. But what will come out of it? So now only the rest. So as in genetic drift we saw, only the rest of the population having this blue color will actually appear out of the thing. And this is so change in gene frequency from an equal probability to a probability of having complete dominance of a blue allele is called as evolution by genetic drift, and it is bottleneck effect. Second is founder effect. What is this founder effect? So I will assume that there is a population, same way there is a population, which has equal probability of both these genes. And then what happens, I will assume then there is a population 2. Population 2 is sparsely populated. Population 2 is sparsely populated by, I am assuming, a third allele. Third allele may be green color. But what happens is that there is a migration, but not any migration. I am assuming there is a selective migration of people only with blue color. Selective migration of people having only this gene. So what will happen is that I am assuming that people are migrating here, and now after a few generations, what will happen is that due to this selective migration, population with the blue gene will start predominating in this population. So if the population which as or the gene frequency which has changed from one allele to the other is not naturally, but because of this selective migration and increase in specific allele to that population, and this is called as founder effect. These two are the process through which genetic drift occurs. But how to write answers? Now we have to come to this factor called as answers. So how to write this answer? So first is the definition, genetic drift. So change in allele frequency because of some environmental catastrophe is genetic drift. And second, this is where please take P naught. A lot of examples are given, but how to write that? You take P naught, collect the geographical examples which are given, and draw a map. Draw a map. In that example, they would have given something called as Amish family. So Amish, what is this Amish? Is because if you see people from Europe, some a set of population or a small family migrated to Pennsylvania in USA, and if you see, as I said, founder effect. That is, first initial small population is there. It selectively migrates to that place, and they also, if you they will have something called as, they will breed only among themselves. So inbreeding will be there. So they will breed among themselves, and hence the gene or the blue gene, in this case this blue gene happens to be something called as six-fingered dwarfism. So six-fingered dwarfism, this actually propagated in a large number. Why this propagated in a large number? Because of the founder effect of population selectively migrating from Europe to Europe to America, Pennsylvania, and breeding among themselves. And second example, they would have given something called as Tristan da Cunha. Tristan da Cunha. What is this Tristan da Cunha? It's a wonderful story where it is an island very near to Saint Helena. Saint Helena, which is the island where Napoleon was incarcerated after his Battle of Waterloo, and he was present there till his death. But here, Britishers, what they did, they had a battalion present, and this battalion had something called as the founder effect. That is, the person who migrated here, the battalion which was there for overseeing Napoleon, had a problem, or the initial people had a problem in their eye, in their retina, which is called as retinus pigmentosa. Retinus pigmentosa. So they had a problem in their eye, and because of founder effect, because of inbreeding, and because of this because of all this, this gene has been propagating in them for a very long time. So this example you can write. And another example, in Southeast Asia, glycogen related problems. Glycogen related problems. So genetic drift, you can give examples as given. And one other example is Pitcairn Island here. Same way, Pitcairn Island is in South Pacific, where it is a British where British battalion was present, and because of founder effect, because of inbreeding, the population seems to have only a set of gene circulating among themselves. And this is the second point you have to write. Third point you have to write. Third point you have to write about founder effect. Clearly you have to write about founder effect, or and what is bottleneck effect. These two things you have to write. So this is the first page. So this is the first page you have to write. Second page, so now comes the second page. So here what you have to write. So fourth point. So 3 points here. Now you have to write conditions necessary. So for what are the conditions necessary for genetic drift? So one condition I said is first condition is small population. Why small population is, I will take this example where if the let us assume if the population is large, they will have more gene. In founder effect, see this, there if I am saying in the founder effect, if there are more varieties of gene, there are more varieties of genes are there, because the population is more. And in this place, if for example selective migration of population occurs, it is very hard for them to have a shift in allelic frequency towards their specific allele, because there are many other genes present and many other alleles present, and the population is large. And hence this allelic frequency or genetic drift works better when the population is small. So you have to write that. Second is inbreeding. And the example I gave was Amish family. That is, they founder effect, they went to America, but they breeded among within themselves. Otherwise, other alleles present in or the other alleles of the gene could have easily managed to come and remove this problem of six-fingered dwarfism. And this inbreeding is also a problem in India, where caste people marry among themselves and families marry among themselves, and that thus creating what is called as this genetic drift of harmful mutation perpetuating in families. Third is chance. So as I said, natural selection happens because of change in natural environment, and hence it is a slow transition of allelic frequency. But here genetic drift happens because of change in frequency of alleles due to chance, environmental destruction, due to any catastrophic event which happened. Hence third point, conditions necessary, is chance. Fifth point, you have to write consequence. So what is the consequence? So if you see, as I said, evolution, change in frequency of alleles. So change in frequency of alleles, I said. So, but what will be the consequences? So I will assume that there is a gene here. I will assume there is a gene here, and there will be gene 1 here. This is gene 2, gene 3, gene 4, gene 5. This gene, all these genes, actually gene does not operate in isolation. They operate as a combination. So they operate in a combination. So I will assume that in one particular population, this gene is present, and this combination will give rise to a particular trait. But there is a genetic drift. Now what happens? There is a genetic drift, and allelic shift happens. So allelic shift happens. So allelic shift happens. Now the combination is different. So now G1, G2 dash, G3, G4, G5. So the combination of alleles is changing. So when the combination of alleles is changing, evolution will have a chance or better trial. Evolution is basically a process of trial and error, and hence this different combination can be checked by evolution, and it is very much essential for evolution. And the conclusion is same. So what is conclusion is, as I told, natural selection is one method, but you can have genetic drift. For genetic drift, for change in allele frequency giving rise to evolution. And this is the question we have got.
So if you like this video, please like, share and subscribe to Minds of Aspirant. You can send this video to anyone who is preparing for civil services and to your family members who want to know about civil services also. There is a Telegram channel, Minds of Aspirant official as well. You can click that link and join the group, and you can ask for whatever doubts that you have. And also you can click the bell icon so that you will get regular updates from Minds of Aspirant. Thank you. All the best.